Welcome to Math with ACE, focusing on statistics. We are working on Venn diagrams, ways that you can display probabilities and perform calculations of probabilities, intersections, unions, and the like. In this problem, we have 40% of students at a local college belong to a club. 50% work part-time. So I know how many belong to a club and how many work part-time, but I don't know how many do both and how many do either, those types of things. If this is a percent, we should have 100%. So it may not be all 100% in the circle, but in our sample space, everything needs to add up to 100%. I know that 40% belong to a club and 50% work part-time. Now I have 5% of the students work part-time and belong to a club. And remember, is their intersection goes in the middle. So they work and they go to the club. That's 5% right here. Draw a Venn diagram. Let C be the club and P being part-time. This means that my club, if I took that circle away and moved it, it needs to sum to 40. And now I already have 5% accounted for. So what's left? 35%. 40 minus 5 gives me 35% left in the club. Same is true for my workers. That circle needs to have 50% in it. It already has 5. That means that 45% is left. 45 plus 5 is 50. Plus 35 is 85%. It's not 100. I need 15% on the outside to make me to 100. That means that 15% do not work and do not go to the club or do not belong to a club. Now I can answer these questions about percentages of people who do belong to a club, who might do both, things like that. So if a student selected at random, find the probability the student belongs to a club. I'm talking a club in general. That was 40%. The probability they work part-time, that was also given. That's 50%. The probability the student belongs to a club and works part-time, that was 5%. What is the probability the student belongs to a club given that the student works part-time? All right, club given part-time. The way that you do this with Venn diagrams is you focus on the circle of the condition they're talking about. This student works part-time. So part-timers of this circle right here, of that 50%, how many belong to the club? That's 5%. So 5% out of 50%, right? These aren't whole numbers, these are percentages, but the total percent is 50%. And 5% of that belong to the club. So that's going to be 5% over 50%. 5 divided by 50 is 0.1 or 10%. Okay. And in your calculator, you would do 5 divided by 50 or 0.5 divided by 0.05 divided by 0.5 if you're turning them into decimals. What is the probability the student belongs to a club or works part-time? Well, or is all the club, all the part-time, and not double counting. So or is everything in the club and the part-timers, but I don't want to double count this portion twice. So what I want to do is I want to say 35% plus 5% is 40, plus 45% is 85% total. Our last question deals with blood type. A person with type O blood and a negative RH factor can donate blood to any person with any blood type. They're a universal donor. 4% of African Americans have type O blood and a negative RH factor. 5 to 10% of African Americans have an RH negative factor, and 51% have type O blood. The O circle represents African Americans with type O blood. The RH negative oval represents the African Americans with the RH negative factor. We will take the average of 5% and 10% and use 7.5% as the percent of African Americans who have RH factor, who have the RH negative factor. Let O equal African American with type O blood and R equals African American with RH negative factor. Okay. So O is blood and RH negative is the factor. I want to fill in the information that's given to me. In the beginning, we were told that 4% have O and negative RH. That means that 4% goes in here. I'm then also told that 51% have type O blood. That's not type O without the negative factor, that's type O in general. And so if 51% make up the total, we already have 4% accounted for. So 51 minus 4% should give me 47%. Because this entire circle O, if you added, that should be 51 total. So 47 and 4 is 51. Now we're told that we're going to take the average and use 75% as African Americans who have the RH negative factor. That's overall. So that entire circle needs to be 7.5%. We already have 4% accounted for. So that leaves us with 3.5% here. Well, 47% and 4% is 51%. Plus 3.5% more is 54.5%. So if we have 54.5%, we need to figure out how much is left over, which is 45.5% that are neither type O or have a negative RH. Now we can answer the questions that we have about and or conditions and so on. The probability of having type O blood was given to us. That was 51% overall. And then the RH negative factor was 7.5%. O and R, that's the intersection where they come together, that's 4%. And then O or R, well, now that we've labeled everything, it's pretty easy. You add the 47, the 4, and the 3.5. Just add the numbers that are in the two pieces. And we got that to be 54.5%. Okay. The overlapping area are African Americans who are type O blood and have the RH negative factor. The area in the rectangle that's outside the circle and the oval have neither type O blood or the RH factor. I find that when I'm given information and just a problem in general, drawing a Venn diagram or a two-way table really helps me differentiate between the pieces, and then I can answer questions using that information. So if you're given a problem and you have probabilities, but it's not organized in any way, I encourage you to try organizing it either in a two-way table, a tree diagram, or in a Venn diagram. And if you find that one way is not working for you, switch to the other one. Thanks for watching.